All right, we want to begin with Chapter 5, Section 1, Video 1. And probably be at least a couple of videos here, maybe 3. But what we want to look at in this particular section is I want to look at what is called a linear system with two equations. A linear system with two equations. Now, let me first of all just say this first. What is a system in mathematics? A system is just simply a group of equations. Just like if you're talking about fish, a group of fish is called what? A school. Or a group of cows is called a herd. A group of equations in mathematics is called a system. Now, what we're going to look at is we're going to look at two equations. So you could have 2, 3, 4, 5, 6 equations and it's still a system. But we're only going to limit our discussion to two equations. But not only are we going to limit ourselves to two equations, they're going to be linear equations. Now, if you look at the first four letters in the word linear, first four letters in the word linear spells line. So if you graph the two equations that's in our system, they're going to both be straight lines. So let me give you a visual of what a linear system looks like. This is what a linear system looks like. Two equations, x and y here are both to the first power. That makes it linear. And if you'll remember, if it has the x and the y in it, that's a slanted line. If it has just a x, it's vertical. Just a y, horizontal. But an x and a y, both to the first power, is a slanted line. Now, your linear system could have circles in it. It could have parabolas in it. That's U-shaped graphs. But we're going to limit our discussion in this chapter to a system with two equations where both of them are straight lines. All right. Now, what I want to do is I want to show you what it means to solve a system. Remember, whenever you graph a line, what does a graph represent? A graph represents all of the points that's an answer to that problem. See, an equation that has two variables, and we've talked about this before, every answer is a pair of numbers. So, if I have this line right here, every point on that line is the answer. So when you graph, you are solving. Now, how many lines do we have up here? You don't have one, you have two. So let's suppose I had a line that looked like this, and suppose I had a line that looked like this. All of the points that's on this line is an answer to this problem. All the points that's on this line is the answer to this problem. What we're looking for when we solve a system is we're looking for the point that works for both equations at the same time. Where would that occur? That would occur where they cross. When we solve a system, and that's what we're about to do in just a few minutes, when we solve a system, what we are looking for is, if you're talking about two lines, you're looking for the point that is an answer to both equations at the same time. And that occurs at the point of intersection. So it's basically where the two graphs cross. So to solve a system means to find out where these two lines cross. That's what we're looking for. Okay. Now, before we get to that, well, let me just show you one other picture right here. You don't have to write this down. I don't know if you can tell on the graph or not. This is green. This is black. So every point on this green line is an answer to this green equation. Every point that's on this black line is an answer to the black equation. This point is on both lines at the same time. Therefore, this point, this ordered pair, that x and y number, would make this equation true and this equation true. So we would call that one ordered pair only the solution to the system. So if I say solve this system, it would be that point where they cross. Now, we haven't talked about how to solve it yet. All right, let me talk about one other thing. If I told you to get out a sheet of paper and draw 2 lines on that blank sheet of paper, there's actually 3 different things that could happen. One is when you draw those 2 lines, they could cross at one point, kind of like what I've done here. But that's not the only option. You could draw the 2 lines where they are parallel. Now, when solving a linear system with 2 equations, there's 3 possible outcomes. One is where they cross at a single point. Your answer would be that point. But do all lines cross at a single point? No. What if the 2 lines are parallel? That means they don't intersect. Well, if they don't intersect, do they have any points in common? No. So it would be no solution. So that's 2 options. But there's 3 possible outcomes. Now, I've had students say before, when you say the word parallel, they'll blurt out the word perpendicular. No, because if they're perpendicular, they still cross at one point, which means it falls into this case. So how can you draw 2 lines that don't cross once and that's not parallel? What's the third option? The third option is if the 2 lines lie directly on top of each other. Now, if the 2 lines lie directly on top of each other, this point is on both lines, this point's on both lines, this point's on both lines, this point's on both lines. So the answer to this system would be infinitely many ordered pairs. So in just a minute, we're going to do about 6 or 7 examples in this section. Every time we work a problem, the answer will either be a single ordered pair like 5, 7, or the answer will be no solution, or the answer will be infinitely many solutions. If the 2 lines are parallel, it'll be no solution. If the 2 lines lie directly on top of each other, which means they're the same line, the answer will be infinitely many ordered pairs. We still haven't talked about how to solve the system. But these are our 3 possible choices when we go to work these problems. Okay, so now what I want to do is I want to talk about how do we solve these problems, these systems. Well, let me first of all tell you what we're not going to do. We're not going to graph the 2 lines. And you say, well, Mr. Rainer, seems the obvious thing to me would be, if you want to find out where they cross, is to graph both of them and see where they cross. Here's the problem with that. What if the 2 lines intersect out in the thousands somewhere? I mean, heavens, I don't want to try to graph way out there to see where those 2 lines cross. Secondly is this. What if they cross at an unusual place? Like 1.473, 2.587. So what if they don't cross at what we call a grid point, where your ordered pair is a whole number? So we're not going to solve these systems by graphing. We're not going to solve them by graphing. Okay, so here's what we're going to do. We're going to use 2 methods to solve the problems. Now, either one of these methods will work at any moment in time. You say, well, then if they both work at any point in time, why do both methods? Let's just do one. The reason is because sometimes one of the methods is a little easier than the other. And I'll explain that as we go through. Okay. So, what we want to do first, there's 2 methods that we're going to use. This first method is called the method of substitution. The method of substitution. Okay, what I'm going to do is I'm going to give you these steps as I go through the problem. This is the method of substitution. Here's the first step. Write this down. Pick one equation and solve for x or y. Okay, so let's look at this problem. I've got this equation up here and this equation down here. I want to solve for either x or y in either one of these problems. Well, the easiest to solve for would be y. And the reason is there's no number in front of that y. So let's take the top equation and get the y by itself. And when you do, you're done with step one. Now, you say, Mr. Randall, why didn't you solve for the x here? Because if you move the y over, if the x has a number in front of it, you have to divide by it. And then you have to deal with fractions. So what I would suggest is, when you're doing the substitution method, always solve for the one that has a 1 in front of it. Now, you say, well, what if none of them has a 1 in front of it? If I ask you to do by substitution, one of them will. So I would not ask you to do this by substitution if this was a 3, a 2, a 5, and an 8. I will make sure that one of them has a 1 in front of it. As a matter of fact, sometimes in substitution, one of these equations is already solved for one of the letters. That really makes it easy because your first step then is done for you. All right, so that's the end of the first step. Now, step 2. Take this down. Substitute, which is where it gets its name, substitute the expression from step 1 into the unused equation. Okay, substitute the expression from step 1 into the unused equation. Now, what equation have we not touched up here? This one. All right, so let's take that one. We haven't used the bottom one, so let's write it down. This is the one we have not used. Now, I want to substitute what I got from step 1 into here. Now, what did we solve for right here? We solved for y. So put this stuff in y's spot. So replace the y with 1 minus 3x. So put whatever you solve for, put that in the other equation. Now, the last two words says, and solve. So let's do that. We've got 2x minus 3 plus 9x equals 8. 2x plus 9x is 11x. Add the 3 across to get 11x equal 11. Then x equal 1. Okay, so substitute what you did from step 1 into the other equation and solve. All right, we're halfway there. We have one of the numbers. We have the x number. Remember, we're looking for where they cross. Okay? Now, step 3, write this down. Use the results from step 1 and step 2 to find the remaining variable. Use the results from step 1 and step 2 to find the remaining variable. Okay? What was the results from step 1? Let me write it back down. What was the results from step 2? Now take this number, x equal 1, and plug it right there, and we'll find y. So y will be 1 minus 3 times 1. which is 1 minus 3, which is negative 2. Y is negative 2. Now step 4, write the final answer as an ordered pair. And you always put the x first and the y second. So that's the answer, 1 comma negative 2. So what does that mean? It means that if I was to graph these two lines, which I am not going to do, those two lines would cross right there. Let me just make up something. So one line may look like that, the other line may look like something like that. I don't know. That's not the point. The point is 1 negative 2 is the answer. Now let me show you something also on this. Let me show you how you can check this if you wanted to. If 1 negative 2 is an answer to these two equations, it should make both of them be true. Let's see if it does. 3 times 1 is 3. 3 plus a negative 2 is 1. Let's check this one. 2 times 1 is 2. Minus 3 times negative 2 is plus 6. And 2 plus 6 is 8. So that ordered pair does make both of those true. And it should if it's the solution to the problem. Okay, let's do another example by substitution. We've got 5x minus 2y equals negative 17. And negative x plus 5y equals 8. And I want to do substitution. Okay, step 1. Solve for either x or y, whichever is the easiest. And you said, wait a minute, I thought you said that solve for the one that has a 1 in front of it. This one has a 1 in front of it. It's negative, but it's still a 1. I definitely don't want to solve for this one, or this one. So this is my next best choice. That's going to be easy to do. We're not going to have a fraction. All right, so let's take the bottom equation and solve for x. When I do, you move the 5y across. Now, you've seen me do this several times this semester. To get rid of that negative, multiply through by a negative 1. And it changes all of the signs. I'm going to turn this around just because it looks better to me and write it 5y minus 8. You do not have to do that. That's step 1. So I took the bottom equation and solved for x. Now, step 2. Go to the unused equation. That's the top one. Now, I'm going to plug this in for x now, because we solve for x now. All right, so put 5y minus 8 right here. But when you do, leave everything else the same and replace the x with 5y minus 8. Put it in parentheses. Now, what does the last two words of step 2 say do? And solve. So I'm going to distribute. 25y minus 40 minus 2y equals negative 17. 25 minus 2 would be 23y. Add the 40 across, so that's going to be negative 17 plus 40. 23y equals 2. That's 23. And then divide to get y equal 1. Now, no, it doesn't have to always be a whole number, but probably the ones I'll be giving you, most of them anyway, will be. All right, let's look at step 3. Step 3 says take the results from step 1 and the results from step 2. So we just found y to be 1, so put 1 right here. So I've got x equals to 5 times 1 minus 8. So that would be 5 minus 8, which is negative 3. And then step 4, write your final answer as an ordered pair. So if I was to graph these two lines, they would cross at negative 3, 1. Or if I wanted to double check my work, go back up to the top, replace x with negative 3, replace y with 1, and that equation should be a true statement. So that is solving a linear system with two equations by the method of substitution. In our next video, we're going to look at a second method to solving a linear system other than the method of substitution.